KU researchers have discovered a new physics effect of electric currents that relies on a process called second harmonic generation. Physics graduate student Brian Ruzicka took the leading role in this experiment.
Essentially, before this, there was only one way to measure electrical current, and that's not really a direct way. So what you do is you measure current by sort of looking at where it ended up. It's sort of like if you're trying to measure the speed of a car, you take a picture before and after, and then you see how long it took for the car to go that far.
However, for electrons, there's still no tool available that allows people to directly see the motion.
What we found is that you can use light as sort of a radar gun of electrons. So the idea is if you have a current moving through a material and you send one light beam to the material, a different color of light will come out, and that the brightness of that color depends on how much current you have going through it. So it's actually a direct way to measure current.
The experiments were performed in the ultra-fast laser lab on the first floor of a Malott Hall, the home of a powerful laser system that radiates light.
To do this experiment, actually, so what we do is we have a pair of electrodes there, and it's hard to see, but those two dots on the top, between that is actually a really tiny gap. So what we do is we apply a voltage across those electrodes, and what happens is a current goes through it.
Additionally, they observed that the brightness of the red light scales with the speed of electrons. When the electrons have no directional motion, no red light comes out. Professor Hui Zhao said the experiment has lasted for over 1 year from the starting point until the last set of data was collected.
I think it just provides a new powerful tool so that we can better diagnostic and we can get more information about how should we design devices and how to improve the material performance.
In the future, they will use this technique to study currents in different materials. For this experiment, they used gallium arsenide, which is commonly used in high-speed electronic devices. For the next material, they will study with graphene, in which electrons move extremely fast, almost at the speed of light. Brian says they expect to find some interesting results in graphene, which is really unique material. Charlene Chen, KUJH-TV News.